the dream was kind of bring back the magic of flying for the customer.
And Boeing's new 787 Dreamliner takes some technological leaps that are revolutionary in the commercial airliner world, even though they're almost commonplace now in general aviation.
We started 10 years ago with a very advanced set of technologies, trying to understand what the airlines really needed to make their operations more efficient and what the customers, the passengers, needed to make the air travel more comfortable.
Since most of us will only ever see the back end of a 787, we'll start there to show you what Boeing did to make things better for both passengers and crew.
This is our first experience using composites for the entire wing and fuselage of an airplane.
And just as we've learned in GA, composites do great things for airplanes. Less weight, fewer fasteners, greater strength. In the 787, that means you're going to feel better at the end of a long flight.
One of the things that composites has allowed us to do is provide a lower cabin altitude, higher cabin pressure, and more humidity for the passengers. Because composites aren't limited as much in fatigue as aluminum structure is, we're able to carry a higher pressure differential across the fuselage than a metal structure would provide, and that allows us to carry a lower cabin altitude.
About 2,000 feet lower. You won't get above 6,000 feet cabin altitude in a Dreamliner.
And that the additional oxygen that additional pressurization brings with it makes a lot of difference in how you feel after a long flight. Additionally, because we're not as worried about corrosion with composite materials, we're able to carry more humidification as well. And so you're going to feel better because of not just more pressure and more oxygen, but also more humidity.
And the strength of composites means Boeing can put larger windows up front and in the cabin.
We're able to have bigger windows because we don't have to worry as much about fatigue, and we don't pay a big structural weight penalty by making bigger windows. And that allows every passenger in the airplane to be able to see the horizon. And that connection with the horizon is really important to your sense of well-being when you fly.
Up front, the 787 is a dream to fly.
You have a lot more visibility out of the cockpit, probably the best visibility of any airplane that we have. And then the other thing is just quiet, and it's very smooth.
Smooth, because the fly-by-wire system incorporates active gust suppression.
You have sensors throughout the body of the aircraft, and they input into the flight computers. And so if you're not commanding the airplane to do something, it will do everything in its power to keep the airplane doing what it has basically been told to do, which is nothing. And so if the airplane starts to roll a little bit in turbulence, the flight controls will automatically cancel that roll out without you even really knowing it, unless you were to pull up the flight control page and look at it.
There's plenty for the pilots to look at.
You see much larger glass displays.
An EFB, electronic flight bag, now comes standard.
The EFB is on either side for a captain, and that runs performance. It also runs your charts for you, any ops manuals or DDGs, that kind of stuff. You can all look it up through here.
The 787 is a mostly electric airplane. Wires have replaced hydraulic lines for most of the flight control system and the brakes.
We're also running 270 volt DC power in some cases for your high voltage large motor controllers, which is something else nobody's played with in airplanes before.
Despite all the differences from previous models, Boeing worked to keep many things the same for pilots.
And we've just got a common type rating on the airplane between this and a 777. And so it's not a common type rating as in 6757 where you get both stamped on your ticket, but it's if you come take a 5-day course, transition course, then you may have 787 and 777 common type rating at that point. So the training footprint has been reduced quite a bit if somebody already has 777s in their fleet to be able to adopt into an 87 versus a 777-67.
The 787 is also easier on the environment.
Well, aerodynamically, it's the most efficient airplane we've ever made, largely driven by a couple of things. The wing, if you look at the wing, it's a very thin wing. It's swept and it's canted, and it's very aerodynamically efficient. It's very thin when you look at the wing, and a lot of that is the strength characteristics that we get from advanced composite materials.
The 787 should burn about 20% less fuel than comparable aircraft, and it makes a lot less noise, even with engines punching out 64,000 pounds of thrust each. Nacelle scallops are to thank for that.
It mixes air, so as the air comes through, some air starts to come here, this is kept off, and then it starts little spools of air coming back, and it basically insulates the air coming out of the core. So if you think about it, this is where all your noise is. This is just fan. And if you look at the footprints of noise, you can take off and climb in your 80 dB airport noise footprint. It's all on the runway. It doesn't go past that, so it's an amazingly quiet airplane.
And Boeing can build them amazingly fast. About a week to assemble a 787 once the production line is up to full speed. Some 57 different customers have ordered Dreamliners so far, with over 850 orders in the book. Tom Haynes, AOPA Live.